Okay, Akib, let's go with your snap for Jammu Kashmir Public Service Commission, and we are going with SOM snap. Okay.
Yes, sir.
Akib, tell me what are the five most important forces?
Sir, sir, which pertaining to what, sir? Can you
In
please,
SOM, what kind of forces you study?
sir? In SOM, we mostly are concerned with like dead loads, live loads. Uh, Mostly the forces are that are governing are like sometimes we take into consideration wind loads as well and seismic loads as well.
Okay, that's a very basic question. What is the difference between a force and a load? Are they same, or is there any kind of difference?
No, sir. I think a force we say for a particular phenomenon like gravitational force,
Hmm.
wind force,
Hmm.
and when that particular force is acting on our structure for which we are
Hmm.
designing,
Hmm.
and a particular suitable quantity of that is estimated, we call that particular as load.
Okay. That's okay. ठीक. Can you tell me what is Hooke's law?
Sir, Hooke's law is related to the uh, stress and strain relation in the deformable bodies.
Hmm.
It states that stress is directly proportional to strain up to some point, which is called a proportional limit
Up to
in normal
proportional.
engineering. Yes, sir.
Okay. Proportional limit.
And sir, the constant that joins this relation is called the modulus of elasticity, which is defined as stress upon strain.
Modulus of velocity. What does it tell you graphically?
Sir, it is basically the slope of stress strain diagram.
Okay. Good. What are viscoelastic materials?
Sir, viscoelastic, they have plastic stress strain curve, and the strain stress strain curve is a function of time as well. They possess considerable amount of viscosity and elasticity both.
Okay. Can you draw the stress strain curve of mild steel in compression?
Yes, sir, I will try. It's like this because in compression you don't get necking as in tensile stresses.
I cannot see. आपका कुछ दिखाई नहीं दे रहा है.
Sir, I hope it's visible somewhat.
आपकी इमेज ही नहीं दिख रही है एक्चुअली.
Okay, sir, I will just. Sorry, sir. एक second.
हाँ.
Sir, because in we don't get necking like in case of tension.
Okay. Good. अच्छा. Likewise, can you draw a graph of stress strain curve of a brittle material? For example, glass. Stress
Yes,
strain
sir.
curve.
Sir,
Hmm.
in that case, it differentiates from elastic material in having less this plastic strain region.
Okay.
Yes, sir.
Less plastic strain. Can you draw it?
Yes, sir. Sir, it will be like this because
Hmm.
thickness is very less in this case.
Correct. Very good. Suppose that the Mohr circle that we are drawing is lying at the origin. Okay. Mohr circle is a point circle at the origin.
Yes, sir.
What does this signify to you?
Sir, it signifies. Sir, is it a simply a point at the origin?
Yes, a single point at the origin, radius is 0.
Sir, I think it represents unstressed condition in which there are
Unstressed.
no. Yes, sir.
Okay, where do you find unstressed condition?
Sir, possibly if a material is not under the influence of any load, we can get that condition.
Okay. What is a plane stress condition?
Sir, in plane stress, a particular element has two faces of the element are without any stress. Sir, there are stresses only on the four faces of a particular cubical element.
Okay, only, okay. which is fundamental? Like when we say stress and strain, if we talk about stress and strain, which is more fundamental?
Sir, I think strain is more fundamental because when we talk about stress, it is only the resistive part that comes into play after we strain a particular material.
Okay. So you are saying that strain is something which we get first, and then we can find stress.
Yes, sir.
Okay. What if I say that if strain is not present, so does it imply that stress will also be not present?
No, sir. I think strain can be zero, even stress may be present. Like there are Poisson effect. If a body is under the influence of two orthogonal stresses,
Hmm.
we may get zero strain, but stress can be there, non-negative.
So can you just elaborate it a bit कि ये strain हमारे लिए fundamental क्यों है?
Sir, when we impose any particular engineering material by external forces,
Hmm.
then under the influence of external forces the material deforms, and in that resistance against external forces the material strains a little bit. As a result of those strains, the material develops resistance against external forces. That's why we say strain is fundamental input.
All right. ठीक है. Correct है. 90% you're very close to the answer. Correct है. Acha, tell me a very basic question. Most of the times, it is taken an assumption that the weight of the structure is neglected. Okay,
Yes,
beam
sir.
is massless, or the structure is massless.
Yes, sir.
What is the application if we consider the mass of the structure?
I think, sir, it's quite comparative when we are dealing with loads that are quite large in comparison to the magnitude of self weight. Then, in such scenario, we can neglect that because it has very minimalistic effect on the design in general. So
Acha.
that's why sometimes we neglect it.
Okay, so which is more? Live load is more or dead load is more?
Sir, it depends upon. We cannot. There is no line that separates the
Suppose that
distance.
you are sitting wherever you are sitting, behind you I can see a building.
Yes,
Okay, what would be the overall weight of that building? Can you just estimate any kind of rough estimate that you can give?
sir. Possibly, I would have to neglect cavities from the if I consider it as a complete brick concrete structure, and I can say, for example, take the unit weight, say for example 2600 kg per meter cube.
Hmm.
So neglecting the watt's total volume minus watt into unit weight total weight.
Roughly, that would come out to be roughly, I guess, 100 tons.
Yes, sir, it can be.
100 tons. It is
Yes,
a very rough estimate. Okay, it can be 60 tons or 150 tons, somewhere like that also. But the weight of that building is going to be very huge. Okay.
yes,
Now, out of that, if I talk about dead load, if the building
yes,
weight of the building is 100 tons, dead load would be approximately, I guess, 80 tons. Finishes
yes,
and
sir.
all. Okay, 80 tons is your dead load.
Yes, sir.
How much live load you expect?
Sir, I think it depends upon the building. If the building is under the influence of frequent pedestrians, then it will be considerable. However, if there is no condition or there are no moving loads, then it will be negligible.
Negative. Just consider it to be 20 tons. However, I'm saying it is very high. 20 tons is very high
Yes,
for
sir.
live load. Okay. Now you see, we have considered dead load as 80 tons and your live load is 20 tons.
Yes, sir.
Okay. Then also we are neglecting this self weight of the structure, 80 tons.
No, sir. I don't think in this structure we can neglect a dead weight or a dead load because
Okay.
it's considerable.
Okay. आपने एनालिसिस ऑफ ट्रस पढ़ा है?
Yes,
उसमें क्या क्या assumptions हैं ट्रसेस के लिए?
sir. Sir, which assumptions like the trusses are pinned. There are no movements
Hmm.
in the trusses. There are axial forces only.
Hmm.
So these are some of the common trusses. The like loads are act only on the joints. There are no loads on a particular member in general.
Okay. Loads act only at the joint. What kind of loading acts?
Sir, normally it's point loads are we can expect at joints.
Can there be a UDL or UVL?
No, sir, I don't think so because sir, yes, sir, there can be like in case of roof trusses. when we use purlins, then UDL can be in the form of GI sheets.
ओके ओके आकिब, ठीक है। देखो, आपका टेक्निकल नॉलेज इज वेरी गुड, कोई कोई इसमें डाउट नहीं। छोटा सा प्रॉब्लम ये है कि थोड़ा सा कॉन्फिडेंस लेके आ जाओ, थोड़ा सा कॉन्फिडेंस। लाइक आप जो भी आंसर बोल रहे हो ना, आप ऐसा ना बोले कि आई थिंक ये, इट्स नॉट लाइक यू थिंक। आपको ऐसे बोलना है कि यस सर, इट इज दिस।
यस सर।
ओके, और जैसे अगर आपको कोई पार्ट नहीं आ पाए, क्योंकि इसके अंदर कोई सा भी ऐसा नहीं है जो कि आप नहीं बता पाए, सिर्फ ये वाला पार्ट थोड़ा सा, एंड आई वाज नॉट एक्सपेक्टिंग कि आप बता पाएंगे दिस पार्ट, व्हाई द सेल्फ वेट ऑफ द स्ट्रक्चर इज नेग्लेक्टेड एंड ऑल दिस। इसका सिंपल सा रीजन ये कि हम सब में ये अजम्पशन लेते हैं दैट स्ट्रेन्स आर लीनियर, प्लेन सेक्शन बिफोर बेंडिंग रिमेन्स प्लेन आफ्टर बेंडिंग। ये अजम्पशन तब वैलिड है जब हम डेड लोड को हटा दें।
ओके सर, यस सर।
अदरवाइज हम डेड लोड को कंसिडर करेंगे तो ये अजम्पशन हम नहीं ले सकते फर्दर से।
ओके सर, यस
और फिर
सर।
हमारा एनालिसिस नहीं हो सकता।
यस सर।
मतलब एनालिसिस कर सकते हैं बट इट विल बिकम वेरी अनकंफर्टेबल, बहुत ही ज्यादा कॉम्प्लेक्स हो जाएगा। टू मेक द
यस सर।
एनालिसिस इजियर, हम ये अजम्पशन लेते हैं दैट प्लेन सेक्शन बिफोर बेंडिंग रिमेन्स प्लेन आफ्टर बेंडिंग। Now this
यस सर।
assumption is valid only when we neglect the weight of the structure.
यस सर।
Okay.
यस सर।
Else, acha, 5 most important forces. First question that I asked you. Very simple. It is tension, compression, shear, bending, and torsion.
यस सर।
These 5 forces. ये तो 5 forces हम पूरे के पूरे सोम के अंदर पढ़ते हैं.
यस सर, यस सर।
We study these 5 forces. Okay.
यस सर।
And Hooke's law you told me correctly. ठीक है. Else it is fine. Next वाले में मैं आपको क्वेश्चंस दूंगा.
ओके सर।
Okay, you will be having questions, so just sit with pen and copy with yourself.
ओके सर।
ठीक है कि बाकी अभी का अच्छा है, कोई दिक्कत नहीं है। कल वाला आपका डाउट क्लियर करेगा सारी चीजें, क्योंकि कल आपको डेरिवेशन हो सकता है, मैं आपको कोई डेरिवेशन दूंगा। फॉर एग्जांपल बेंडिंग वाला मैंने आपको डेरिवेशन दे दिया,